Alright, so, fellow Mopar degenerates, I'm basically on the last stage of getting this car ready for cruising season. So, got all my glass in, hood emblem installed. Took me 3 tries, but finally got it installed right. That is one big ass detail. Do not recommend doing on your own if you're not good at that stuff. I am not. So, current task at hand is I'm trying to verify that the Hellcat power steering pump is going to play nice with my Hydrotech Hydro Boost and the altercation rack and pinion that is currently on my car. So, if you're not aware, a lot of these rack and pinion setups like a lot lower pressure and flow rates than what you would see on like a recirculating ball gearbox. So I need to make sure that the flow rates and the relief pressure on my power steering pump are going to be compatible with these two components. So there's really 2 things you got to look at. It's not just all about relief pressure. Flow rate is equally as important. When you have too much flow rate, your line pressure, basically when the car is just going straight, there's no load on the power steering system, if you will be elevated, right? So if you have higher flow rates, you're going to have higher line pressure. And that is what ultimately causes that overboosted, twitchy, overly sensitive handling that some people will complain about when they have too much flow rate going on. Relief pressure is not the issue in that situation. It's actually the flow rate of the pump is what's creating the problems. So the other component is your pressure relief. Ultimately, when you turn your steering wheel to lock, when you hit those locks, that's when the relief pressure comes into play. So on the Hellcats, it's rated at 1700 psi of relief pressure and about 3 gallons per minute of flow rates. The Hydro Boost wants about 2.5 gallons per minute, and anywhere from 1350 to 1450 psi. Of the 2 things, the Hydro Boost is a lot more forgiving and less sensitive than the rack and pinion. The rack and pinion that the altercation setup uses is a late 70s, a 79 through 93 Mustang style rack and pinion. The earlier Mustang 2s were really low pressure designs. I mean, anything more than about 900 to 1000 psi was too much for them. The later model rack that this one uses can handle up to about 1200 psi. I think 1260 is the official rating. So again, flow rate's going to cause your twitchy handling. Excessive relief pressure, on the other hand, is going to damage components. So turning lock to lock, you're running the risk of blowing out your rack seals with too much pressure, if not bending or damaging other components. So I definitely don't want to deal with that once I start driving this car, so I need to make sure that everything's good to go before I have to down it mid-season. So I ended up buying a power steering analyzer, which is already hooked up to the engine. These have come down a lot in price. I mean, this is a name brand, I think, Kent Moore tool. SBX, Kent Moore, OTC, they all sell these brand new from anywhere from $750 to $1,200. I was able to score this brand new in the box, name brand, for $50-something shipped to my door. So these are nifty tools if you're doing any power steering testing like I'm going to be doing, because you have a gauge here that will measure your line and relief pressure. You have a flow meter here, which, by the way, is directional. If you install this backwards, you're going to have a really bad day. So yeah, you can see there's a little arrow. There you go. That measures your flow rate while you're running. And then you have this valve here, so you can basically deadhead the pump for no more than 5 to 10 seconds, because otherwise you'll overheat and damage it very quickly, to test your relief pressure setting. So that's what we're going to be doing. I've already done a baseline, actually, so it's too hard to film and hear it over the engine idling and running up and screwing around with the valve and everything. So what I ended up measuring on this car with the Hellcat pump, completely stock, was it did in fact hit 1700 psi of relief pressure and just short of 3 gallons per minute of flow rate. So that's higher than what I need to do or need to use. So I'm working on dialing that in, right? So I've got a number of power steering outlet fittings, which are really flow restrictor fittings. These are really what control your flow rates. And then you have the pressure relief valve. this is what's obviously controlling your relief valve setting. So I ended up finding a lot about these pumps, these Toyota style pumps that they use in the Gen 3 Hemis. There's a lot of confusion and a lot of misinformation out there. One of which is that these are all interchangeable. They absolutely are not. So even though I've got an assortment of pumps here, so I think from left to right I have an old early 2000s Camry pump, an El Cheapo Chinese Amazon replacement pump for Tacoma, 2nd gen, also early 2000s, a Hellcat pump, and this is, I believe, a early 2000s Corolla pump. Now, they're all virtually identical. The pump castings, the bodies are very similar. The actual Toyota models, get this damn thing out of the way, have a casting and a boss in here for a power steering pressure sensor. But other than that, internally, these things are damn near identical across the board, which is good because it means these valves can be interchanged. Where you run into trouble, though, is the restrictor valves, or the relief valves in the restrictor fittings need to match each other. So you can't just mix and match everything you want. So unfortunately on a lot of the Toyota stuff, they use a banjo fitting, which isn't compatible with your, your Dash 6AN fittings like we normally use. So I found that out very quickly. The other thing is, too, these relief valves, some of them have this little stubby end on, which also makes it incompatible with a lot of the restrictor fittings. So starting from, let me figure out where the hell I'm at. So this is an aftermarket 2.5 gallon per minute flow restrictor fitting from TurnOne. So this is ultimately what I'm going to be using to dial in my flow rate. This is a factory Hellcat restrictor fitting. It's set up for a M16 by 1.5 O-ring fitting for the hose end. And you can see it's got this just flat nub on the end after the restrictor outlets. Here's the pressure relief valve. You see this one's flat, but it's got a little check ball in that end, and underneath the screen here is another one. So this is the one that really controls your pressure relief. There's a check ball, and I don't know if you'll be able to see it, but yeah, you can see the spring inside there, right? So this one's marked with a D, and I'm not really sure what the markings correspond to. They do not correspond to pressure ratings, because from what I've seen, and I'll go through it, so this one is a D, right? This is rated for, 1650 to 1750 psi of relief pressure. What else? This one is also a D, but this one also had the completely different nub, which I've ground and epoxied off. And this one is only rated for, like, I don't know, 1100, 1200 psi. Again, marked with a D. Then I have the Corolla valve. This one was also equipped with this extension that I ground down, and it's marked with a C. And this one's at about, I think a little, like almost 1100 psi, give or take. So the weird thing is the pump bodies are actually, the factory ones at least, are stamped with a letter on them that is supposed to correspond with whatever relief valve's going in there. Now, again, these bores are all identical. There's no difference in the tolerances between any of these pump bodies or these pressure relief valve diameters either. So the only thing I can think of is they match these letters with a given pump, just so very quickly on the line or in service they can tell what pump is installed. Whether you're using a Corolla or a Camry pump. But again, it's not apples to oranges, because I've got a 500, 600 psi spread in pressure relief settings with the same marked valve, and even the valves themselves are different designs. So these ones with these long extensions, they don't have a check ball on this end, but they have this little nub. And unfortunately, that nub has to fit into the end of the relief valve. Otherwise, it won't seat right. You'll have too much stack up here, and it's going to cover or uncover, I should say, certain ports in the casting of the pump. And what'll happen is, if you start it up, and I found this out the hard way, you'll have absolutely no line pressure whatsoever. So I think what happens is it uncovers the port and it just recirculates. So it's acting like it's in full relief mode at all times. So yeah, it's kind of a mess here. I bought a bunch of pumps. I was trying to find one that had the same form factor is the factory Hellcat valve, just in a much lower pressure. And they're out there. I'm confident that some of the second gen Tacoma pumps are probably exactly what I need, where they're the same body setup, but they relieve at about 1200 psi. I ordered a super cheap aftermarket Amazon pump, really just to take out the relief valve. And unfortunately, what I ended up with was this. So in the aftermarket, I have a feeling they're just mixing and matching stuff. As long as it works and it's close, that's okay. But this is going to cause a problem. So what I'm going to end up doing here is grinding this off. And because I think this is an aftermarket valve, I might get lucky and not uncover a hidden porthole here like I had epoxy on these other two valves. These are my last ditch effort if nothing else works. I have concerns with having an epoxy or JB Weld covered port on the end of this valve. I don't know how much pressure this is going to be withstanding. And I really don't want that breaking loose and going through my steering system and destroying thousands of dollars worth of stuff. So this is an absolute last chance, but I don't want to run this. So I'm hoping this aftermarket valve, because I opened it up already, I can just grind this down to get the right height I need to match the rest of these valves, and I can use it. The other thing with this aftermarket valve that you will not see in a factory application is this actually has a serviceable check ball assembly with shims, just like you have on a lot of the old school power steering pumps. The rest of these do not. They have this pressed and staked in cartridge with a, you can see there's a little screen in there, but I destroyed one valve trying to remove it, and I couldn't get it out without destroying the valve. So worst case scenario, if I can grind this down and this all works as expected, if I still need to tweak the pressure a little bit, I should be able to add and subtract shims at the end of here to get the pressure I need. So I'm going to give this a go, and I'll report back with my test results, and hopefully everything is a-okay. And if that's the case, I'll let everyone know what that secret recipe was, so that you don't have to spend a small fortune and way more time than you should on figuring out power steering pressure. One last thing I'd mention before I start cutting up this valve. So I took the guts out of it just so you could see what's inside with one of these. And it's identical to the non-serviceable factory style valves. So you have a pressure relief spring in here, you have this little piston, check ball, and then your ball seat at the end here. The difference being that this is obviously threaded instead of pressed and staked in, and then you can see there's a couple of super thin shims here. So I don't know. This is obviously aftermarket only, and my guess is this is a one-size-fits-all pump. So if this were truly an OE style Tacoma pump, this should relieve at about 1250 psi, which is exactly where I want to be. We're going to test this one out as is and see where it goes. Hopefully it's right where it should be. If not, I can adjust it up and down just to be a little bit messier and bigger pain in the ass than I want to deal with. But such is life. Alright, so here is our finished product. So I reassembled this. You can see all I did was grind this down, and come on, girl. Luckily enough, this doesn't have a blind casting where it just goes through into the body of this. So that's the issue I ran in the factory valves. That end piece was steel and pressed in, and once you ground it down, there was just an empty passage there. I had epoxy. So that's going to work out well. This, I just nicked it. It literally just took off the surface coating, so I didn't damage the valve at all. So that little guy, I wouldn't worry about that little guy. And if you compare it in terms of height, or length I should say, the working area of the valve, it's basically the same length now. It's really hard to get a view. It's close enough. I mean, this valve's going to shuttle back and forth as needed to compensate. So I'm going to go ahead and install this and hope for the best. One other cool thing I forgot to mention about this power steering analyzer is it comes with these clean break quick disconnect fittings. So these have Schrader valves in each side of the fitting, so when you disconnect them, they don't leak everything out in the line. You just get a couple of drops as opposed to making a giant mess. Not that that really matters, because I had to take the pressure relief valve and the flow restrictor fitting out. And when you do that, this entire reservoir is going to drain down anyways. So you're going to make a big mess if you don't have a way of catching it. So you've been warned. some air in there, not a big deal. But this is what I was talking about earlier with your static pressure. So your line pressure, when there's no load on it, you're not turning the wheel, really should be under 150 psi. What will happen is if you have too much flow rate for your setup, higher flow with the higher restriction is going to equal higher pressure. So you'll start seeing this gauge creep up here under higher flow rate. And when you're going down the road with 400, 500, 600 psi steering effort, it's going to be very twitchy and overboosted. So you really got to match your higher RPM flow rate with whatever the rest of your components need. So right now we're sitting at idle. Again, we're like 100, 150 psi. On this car, you're supposed to measure flow rate at 1200 RPM. I can't really do that with the camera in my hands, but what I can tell you is the flow rate right now is probably sitting at about 2 gallons per minute flat. When I raise up to 1200, it goes right up to 2.5 like it should, which is just about perfect. And the line pressure stays well under 200. So that's ideal. I shouldn't have any issues with the way the car steers or brakes. As far as relief pressure goes, let's see if I can do this. So I got the knob here, I'm going to turn it in. There's still some air in here, so it's going to jump around a lot. Let's see what we got. You'll hear the pump start loading up and whining. There we go. So I would call that about 1100, 1150 psi. That's about 100 less than I wanted, but it's definitely at a low enough point where it's not going to harm any of the components from excessive pressure. So what I need to figure out is whether or not I'm going to be able to steer the car adequately at low speeds. So that's really when your relief pressure is going to come into play, is when you're turning lock to lock or really slow speed maneuvering. Like if you're stopped with the way the vehicle on the ground turning the wheels, this pressure is going to creep up and potentially butt up against that relief pressure. When it does that, my steering assist is going to fall on its face. So ideally, I can hit the locks, even with these badass tires, on the ground, stopped, before it actually hits the relief pressure. So I'm going to test that, we'll see how it goes. If I have any issues with low speed maneuverability, I'm going to have to pull that valve back out and remove some of those shims to increase the preload on the check valve and spring, which will consequently raise the relief valve pressure. Well, I'm done testing. I need to let this thing cool down before I remove the power steering analyzer, hook up the line again, and I have to degrease this entire engine bay because I got little power steering droplets probably everywhere. And I'm really OCD and I don't want messes on a brand new car. So yeah, anyways, pleased to announce mission was successful. I don't know if you could hear me. I haven't listened to the audio yet with the engine running, but I swapped the modified pressure relief valve. When closing the valve on the power steering analyzer, I got about 1150 psi, give or take, and my flow rate pegged out at 2.5 gallons per minute as expected at about 1200 RPM. And I actually went past that to see if it would keep creeping up, but it didn't. At idle speeds, it's probably around 2 gallons per minute. As soon as the RPMs come up, the flow rate starts to come up, and then it just flatlines right at 2.5, just like it should. So the one thing I was concerned about was because the relief pressure is about 100 psi less than what I was shooting for, was that I might have some low speed drivability issues. So if you go too low on your pressure relief setting, what'll happen is when you go to turn your wheels, depending on how wide your tires are, how heavy the front end is, if you're completely stopped or rolling, that turning effort is going to cause your line pressure to naturally raise up, and it could butt up against your relief valve setting. That should only hit when you actually hit the locks. So if you hit that relief setting when you're still maneuvering the wheels, you're basically going to lose all your power steering assist, or it's going to be very erratic. It's going to be very hard to turn. It's not going to be pleasant. It's going to be like manual steering when it's working and power steering when it's not. So what I did was I lowered the vehicle on the ground, turned the wheels as quickly and abruptly as I could, not at the locks, just to simulate, the quickest low speed maneuvers stationary with all the weight on it as I could. And I never saw the gauge jump past 800 psi. So that's really good. That means I have several hundred psi of buffer. Even with this big ass Hellcat engine and the 275 millimeter wide tires, I don't think I have to worry about anything. So I'm going to roll with it. Need be, I can always go back in there and remove some of the shims to increase the preload on the pressure relief valve spring. And that should get me where I need to be. But it worked. So, science project, long story short, if you have the same setup and you don't want to waste time getting messy, buying a shitload of parts, modifying things, buying this power steering analyzer, and you just want to run with what I have, do at your own risk, go to TurnOne.com, I believe. Either way, it's TurnOne. You'll know if you have the right one because all they sell is power steering stuff. Buy their 2.5 gallon per minute flow restrictor fitting for a Cadillac CTS-V. Yes, it sounds weird, but the CTS-V, for whatever reason, some of them actually use that same Toyota pump, or one extremely similar to the one that comes on these engines, of all things, as well as the Toyotas that they actually originally came on. So get that part. And then, if you're a gambling man like me, go to Amazon and for about $50-$60 shipped prime, order yourself a brand new aftermarket power steering pump for a 2005, 2006 and up Tacoma with a 4-liter. And what you'll do is you'll take that pressure relief valve out, just like I did, and you're going to just machine the very end down. When I say machine, I use a frickin' belt file and an angle grinder. So, it doesn't have to be super scientific, but basically what you're going to do is try to shave the top of it off so all you have is this little lip kind of matching the original valve that you're going to pull out of your power steering pump. You slam those two things in there along with the original relief valve spring, and you should be golden. So, yeah, stay tuned. Hopefully this helps somebody and saves you all a lot of time, mess, headache, and experimenting. Good luck.